Hey guys, today I'm going to show you how to find the inverse of a 2 by 2 matrix. So let's check out the rule and see what you think here. First of all, we're going to talk about this matrix A, which is given to us as A, B, C, D. And as far as notation goes, if I ask you to find the inverse has a little -1 up here. So if I say find a to the -1, I'm really asking you to find the inverse. Now in order to find the inverse, you just follow this fairly simple rule. The rule is like this, looks like this. You take 1 over top of the determinant of A. Remember from last time, if it has parallel lines, it doesn't mean absolute value, it means determinant when we're talking about the matrices. And then you take that fraction times this matrix A rearranged. And what they do is they switch places with A and D on the diagonal, and they make B and C their opposite values. And so we're going to show an example of that right now with this matrix over here. I have a matrix 8, 2, 10, 4, and I want to find the inverse of that matrix. Well, the first thing I want to do is find the determinant of that. And so to find the determinant, two parallel lines there mean determinant. We multiply on a diagonal. We'll take 8 times 4, which is 32. And we'll take 10 times 2, which is 20, and we subtract those. 32 minus 20 gives us a value of 12. So 12 is our determinant. Now if you look at the rule up here, we put 1 over top of that number times this matrix kind of rearranged. And so we put 1 over top of 12 times, if we look at this rule, they switch places with the A and the D values, which in our situation is 8 and 4. So I'm going to put 4 there and 8 down there. And they make these two values their opposite signs. So negative and negative would be -2 and -10. Now, if there is a quantity on the outside of a matrix, what we usually do is we just distribute that by multiplying. So we're going to take 1/12 times all of those values, which really would result in putting these whole numbers over top of 12. Now, so I would have 4 over top of 12, -2 over top of 12, -10 over 12, and 8 over 12. Now, some of you are thinking, well, some of those almost all those will simplify. And so you should simplify these fractions into its most simple form. And I think for the most part, keeping it in fraction form is a little nicer than going to decimal, because of the whole repeating decimal issues that sometimes arise. So like this one, 4 over 12, that would be 1/3. 2 over 12, -2 over 12 would be -1/6. -10 over 12 would be -5/6. And 8 over 12 would be 2/3. So that would be this inverse in its most simple form. So this guy right there now would be the inverse of our given matrix. Now, there's another thing that we're going to do with these matrices. Sometimes it's nice to know whether or not two matrices are inverses of one another. And I have an example over here that talks about that. So let me move this over a little bit so we can see that. And there's a matrix, a 2 by 2 matrix has an identity matrix, which the identity matrix has positive 1s on the diagonal and 0s on the other. So the identity matrix of a 2 by 2 is 1, 0, 0, 1. Now the identity matrix is a lot like 1. Okay, if you multiply anything by 1, you get that value. And the identity matrix works the same way. If I take that identity matrix times any other matrix, I'm going to get that other matrix. So we'll be working with that idea in the future. But one thing that is interesting is when you multiply two matrices together and you get the identity matrix, then those two matrices are inverses of one another. Okay? So I have an example here. I have P is 2, 3, 1, 1, and I have Q, which is -1, 3, 1, -2. Now, what I'm going to do is I'm going to see if these two things are matrices, or inverse matrices of one another. And I'm not going to use the formula I just used. I'm just going to multiply them and see if I get that. So, if you recall multiplying matrices together, when you multiply matrices, you multiply the rows of the first times the columns of the second. And so I'm going to multiply this 2 by 2 times that 2 by 2, and I'm going to get another 2 by 2. And a 2 by 2, keep in mind, that's 4 places. And to get this first spot, I'm going to take these two values in the first row, which are 2 and 3, and I'm going to multiply them by these two values in the first column. So the rows of the first times the columns of the second. So I'm going to take 2 times something plus 3 times something, and those somethings are going to be -1 and +1 in that first place. Then over there, I'm going to still take 2 times something plus 3 times something, because those values are still in the first row, but those somethings are in the second column, so I want to take 3 and -2 there. Now I'm done with the first row, at least the setup of the first row, and I'm going to use the second rows. I'm going to use these values, 1 and 1, and I'm going to take 1 times something plus 1 times something, 1 times something plus 1 times something. And those somethings are going to be in the first column, they're going to be -1 and 1. And the second column is going to be 3 and -2. So if I do some arithmetic here with these, this is going to give me 2 times -1, which is -2, plus 3 times 1, which is 3. And so I'd have -2 plus 3, which is 1. If you notice here, I have 2 times +3 plus 3 times -2. That would be 6 plus -6, which is 0. So far I have 1 0 in my first row there, which is a good sign. Here, if I take 1 times -1 plus 1 times +1, I would also get 0. And over here I have 1 times 3, which is 3, plus 1 times -2, which is -2. 3 and -2 is +1. So if you notice, I get 1 0 0 1, which is my identity matrix, which basically tells me this, that P and Q are inverses of one another. Okay? If you're in my class, I'm going to ask you to do both things. I'm going to ask you to find the inverse of a matrix, of a 2 by 2 matrix, and also show that matrices are inverses by multiplying. So I hope that helps you figure this out, and have a good day.